Now we start with build up your understanding. Okay, let's have a look at the first question. Okay, this is a good question actually. In an announcement on a railway station, a passenger hears that the last train has passed the station delta T1, that is equal to 30 minutes earlier than his train. Okay, on the next station, that is 20 kilometers away, that is S distance away from the previous station, in the another announcement he hears that the first train arrived delta 2 equal to 20 minutes earlier than his train. Okay, reading time from his watch. Okay, he calculated the average speed of his train to be 60 kilometers per hour. Relying on the announcement and the passenger's calculation, determine the average speed of the first train. Alright guys, so the situation is this. Let me break down the situation for you. This is the route. Let's say this is station 1. Let's say this is station 2. The distance between station 1 and station 2 is 20 kilometers, which is denoted by the symbol S. Okay, so this is 20 kilometers. Now let's say the passenger was here at some time. Okay, let the time be t. Okay, now the passenger is hearing an announcement which says that there was a train on this station which was here 30 minutes earlier. Okay, so if train 1, okay, like let me draw this as train 1. Okay, this is train 1. For train 1, the presence of train 1 at this location in space is at time t. Then the presence of train 2 at the same location would be at time t minus 30 minutes. Check this. Whatever time t is there, minus of 30 minutes. So train T2 was present at the same location in space at a time t minus 30. Okay. Now T1 reached here at some time, and if the question says that the average speed of this train was 60 kilometer and it was 20 kilometers away. Okay. So how much time train 1 would have taken to travel from here to here? Train 1 would have taken a time of 20 kilometer divided by its average speed, which is 60 kilometer per hour. Okay, so it must have taken 1/3 hours, or if in minutes it would be 20 minutes, right? 1/3 hour, that's 20 minutes. So train 1 would be here when the watch shows the time of t plus 20 minutes. Okay, now according to the announcements, train 2 existed at the same location in space 20 minutes prior to this time, which would be like t. Okay, so train 2 existed in this space 20 minutes prior, so that would be time t. So if I look at train 2 was here at a time t minus 30. Train 2 is here at a time t. So what is the time taken by train 2? Actually train 1, like in this question, this is referred to as the first train, but in any case I have been referring to it as the second train. So this train traveled from this point to this point in a span of 30 minutes and the distance was 20 kilometers. So what was the speed? That would be 20 kilometer divided by 0.5 hours. So 40 kilometer per hour is the speed of the train, which I am calling as second and the question is calling as first. The important thing is answer is 40 kilometer per hour. Alright students, okay. Now this question says, one day you were on a picnic with your class. That's good. During return journey from the picnic spot to your school, it began to rain. Therefore the driver reduced the speed of the bus, good driver, and drove with an average speed of 60 km per hour instead of the scheduled average speed of 70 km per hour. Alright, I think 60 km per hour is still fast. Anyways, okay, after the rain stopped, the driver drove the bus at an average speed of 75 km per hour and covered the remaining, this is important, we have been given the remaining distance, that will come handy. Exactly scheduled time, how long did it rain? Now guys, what is not given to us is what was the actual distance between the picnic spot and our school. We don't know this distance. Okay, we don't know this distance. Okay, but what we know is that out of this distance S, which is actually 40 kilometer, okay, this distance was covered at a speed of V2, which is 75 kilometer per hour, right? Average speed of 75 kilometer per hour, and yep. And then what happened? So how much would be the time taken? So this time would have been 40 divided by 75 kilometer per hour. So in hours this would be 8 upon 15 hours, and if we write the same time in minutes also, This would be 32 minutes. Okay, I hope I'm doing everything okay after another speed of okay. Now guys, this much part we have done. Now this distance was covered in with a speed of 60 km/h. Okay. Now guys, if the entire distance would have been covered at the speed of this is 70, this was the scheduled speed. Okay, so d divided by 70 is the actual time that or it is the scheduled time, that the time that, and it is in hours. Okay, this is the time the bus should have taken to return from picnic to school. Okay, okay, so it traveled this distance is d minus s, so 70 into t kilometers minus s is 40 kilometers. This much was covered, this distance was covered with a speed of 75. So this should have been the time taken. This represents the time taken for journey from this point to this point. Okay, I hope you get this. Okay, the total distance will be written as t into 70. So total distance minus s. So that gives me this distance divided by the speed with which this distance was covered. The speed was 70 actually, not 75. Okay, so that gives us the time, to cover this distance plus this much hour is, okay, what is this? This is t, the total time, because ultimately the total time of the journey remains same. Okay, so let me solve for t now. Let me solve for t. Did I mess up? Guys, I think I'm okay. I did a mistake here. It was 75 only. I wrote the correct value. So he drove. No. Guys, here I wrote the wrong value. It should have been 60. The average speed was 60. I captured it as 70. And therefore all the problems that is happening. So the average speed was 60 here, so this should have been 60, this should have been 60. Okay, this should have been 60 and minus, and then the speed with which he drove slowly, that was a speed of 7. No, okay, this was correct, and this was 60, okay, everything else was correct. So I messed up with this number. Okay, now let's solve. So this would become 7t by 6 minus 2 by 3 plus 8 by 15 is equals to t. Okay, so let's bring it to this, let's bring that to this to that side. So this will become t by 6, 70 minus 60. Okay, this is equal to 2 by 3 minus 8 by 15, which is 2 by 15. Okay, so the time t would be 2 into 6 by 15, so 4 by 5 hours. Okay, 4 by 5 hours. So if we now know the value of t, the question is asking us how long did it rain. So we want to calculate the time for this journey. Okay, so how much was that time? That time was this much part. Okay, that time was this much part. So we will do 70 into t. Okay, so 70 into 4 by 5, 70 into 4 by 5 minus 40 divided by 60. This should give us the answer. So this is what, 14 into 4 is 56, minus 40 is 16. So this is the answer in hours. If we convert it into minutes, it is 16 minutes, which is the answer. So guys, I think I messed up here a bit because I picked up the wrong values. Actually, I picked up the right values. Then I thought that I picked up the wrong values, and then I checked again. I was only the value that I actually picked wrong in the first place was this number. In any case, this is the solution. I hope you have understood the solution. It was not a complicated question. Okay, just because I had to go back and check the values, it caused a bit of problem. Anyways, okay. So what is the answer? Answer 16 minutes as we got it. Okay, next question. That's a good question. That's a very good question. So it says there is a narrow bridge somewhere on a road connecting two towns. Okay, two cars travel from one of the towns to the other with a constant speed v1 everywhere on the road except on the bridge where they travel with a constant speed of v2. Okay, how the separation s? Now guys, this s is the separation between the cars. Okay, varies with time t as shown in the following graph. Okay guys, so we'll come back to this graph later on. First, let's see what is happening in the physical world. So what do I mean by that? So let's say this is the road, okay, which doesn't look like a very straight road. So this is the road, and on this road there is some section which is actually the bridge. Let's say from here till here, this is the bridge. Okay, now there are two cars which are traveling at the same speed, and that speed is v1. This information means, now let me denote both the cars as dots. So whatever distance is there between these two cars, this is going to be maintained. Like this is going, this car is going with a speed of v1, this car is also going with a speed of v1. So the separation between them will be maintained. Okay, so we can imagine that this separation will be maintained till this point. Okay, so let us try to understand, like let us try to draw the graph and then compare with the given graph. I think that will give us more insight. So what I see here is that initially the distance will remain fixed. So I can expect like this, okay, a fixed, constant graph till what time? Till the time when the first car starts on, it climbs the bridge. Like here is one car, the other car, so distance between them is whatever, it's s actually. Okay, now this car started traveling, it is traveling with v1, but this car is now traveling with v2, which is less than v1. As a result, the rear car will start catching up on the above car, or on the front car. Okay, so we can now expect this to go down. This will start decreasing. Now there can be two situations. One situation is that the bridge was so short that even before the first car could get on it, the rear car could, let's name it as x and y. So even before the x car could get on the bridge, y car came out of it. That is one situation. The other possibility could be that while y car was still on the bridge, x also got on the bridge. So let's see in these two scenarios how the graph will change. So if the bridge was very short, okay, then what will happen? This will decrease. Then y will get off the bridge and x is yet not on the bridge. Okay, x is yet not on the bridge. So once y crosses the bridge, x is yet to come on the bridge. They will again start traveling with the same speed v1. So the distance between them will stop changing, so it will become a constant value. I'm drawing this graph for the first scenario. Okay, and then what happens? Then x climbs the bridge, and when x climbs the bridge, x becomes slower, y still going with v1, so the distance between them begins to increase, and it increases, and it again restores the previous value, and then they, so this is the kind of graph that we will see in the first scenario. What was the scenario? That y gets off the bridge while x is still, it's yet to climb the bridge. Okay, so y gets off, then x climbs, then x also gets off. So this is the case we are getting. Now what happens in the other scenario? So till this point I believe everything was same, everything will be same. The graph will start decreasing. Now y is still on the bridge and x also comes on the bridge. So even in this case, once x and y, they are both moving on the bridge, they would be moving with the same speed. So the distance will again become constant. Like the qualitative nature of the graph will remain same. It will become constant. Then y gets off the bridge, so distance will start increasing. So at least the shape remains same. So what we understand is that the two scenarios that we have covered will not create a difference in the shape. Okay, in both the cases, the shape is going to be like this only. So I don't need two shape. And understand that what are the corners in this graph indicate? The first corner indicates front car going on bridge. This indicates first front car climbing on the bridge, like it begins, it starts, okay, going. Okay, what is the second corner indicate? Second corner indicates the second car climbing on the bridge. Is it just a minute? No, the second kink can represent either the, okay, in the first case, because this car got off, because the Y car got off, therefore the distance starts. So it represents first car getting off bridge. Okay, this was the scenario 1 that we talked about. Or it can also represent second car, or which is car X, okay, climbing bridge, okay, in scenario 2. So in the two scenarios it is different, okay. In scenario 2, now what was scenario 1? Y gets off the bridge while X is yet to climb the bridge. And what was the second scenario? Y was still on the bridge when X climbs the bridge. Okay, so the second corner can denote any of the two events. Okay, now what will this point indicate? Okay, in the first scenario, when Y gets off before X, Y gets off before X climbs. Okay, so in the first scenario, this will represent Y got off, now X climbing the bridge. X climbing bridge. This is scenario 1. Okay, or it can represent, now in scenario 2, both of them were moving together, so Y getting off the bridge. So Y getting off bridge. This was scenario 2. Okay, and finally, what does this represent? Okay, so in scenario 1, X climbed the bridge, so this is the final point. So in this case, X climbs off. Okay, X climbs down, like it is coming off the bridge. So that is scene 1. Okay, or in scene 2, they were both traveling together, Y got off, now again X has to get off. So this represents the same. For example, this was unambiguous. This was sure that the first car, the front car is, the Y car is getting on the bridge. Likewise, this is sure that the second car is getting off the bridge in both the scenarios. Okay, ambiguity lies here, or case-wise difference lies here. Okay, so now our shape matches with the shape given. Let's start analyzing what is going on. So according to the given data, initial distance between the car was 500 meters. So the initial separation between the car was 500 meter. Okay, all right. Okay, and then what happens? Here we are very sure that the front car gets on the bridge. Okay, the front car gets on the bridge, that is we are very sure. Okay, and what happens here? So front car gets on the bridge. Okay, here the front car getting off the bridge. If the front car gets off the bridge, distance becomes constant, which is 200. Okay, so this distance would have decreased. Okay, so we can make this equation now, like during this one car was on the bridge, the other car was off the bridge. So the relative velocity, we can make an equation here. The relative velocity, like v1 minus v2, would be slope of this line. So that would be 300 by 20. So that's 15. Now that's one equation. v1 minus v2 will be 15, and this is again, this is applicable for both the cases, whether it's case 1, whether it's case 2, this is applicable. And here also we are getting the same value, because see, this is again 20 seconds, so this will match. Okay, now what is the speed v1 of the cars on the road? Okay, so guys, let's understand this. According to scenario 1, the front car, the Y car, got off the bridge in 20 seconds. Okay, so V2 into 20 will indicate the length of the bridge. This is scenario 1. Let me solve it scenario wise now. Okay, so scenario 1, scenario 2. What was the scenario 1? If this is the bridge, okay, if this is bridge, then in scenario 1 it was like X is still here and Y have got off. Okay, X is still here and Y has got off. So Y took 20 seconds. Y took this much time, which is 20 seconds to cross the bridge. So we will have 20 into V2, because on the bridge the speed of Y would be equal to V2. This is equal to L. So in scenario 1, this is the situation. In scenario 2, what we are saying, that if this is the bridge, okay, then X and Y, they are moving on the bridge together. So this event indicates X climbing on the bridge. Okay, the second car climbing on the bridge. So when the first car reached the bridge, the time was 10 seconds. Okay, and when the second car reached the bridge, the time was 20 seconds. Okay, in this case. So when first car reached the bridge, okay, at 10 seconds, the second car was at 500 meter behind car 1, and then the second car reached the same spot in the next 20 seconds. So this car must have traveled with a speed of 500 by 20. So this is V1, this is 25 meter per second according to the second scenario. Now, according to the first scenario, whether we get the same speed or not, that is yet to be seen. What else can we talk about in the second scenario? Now, in the second scenario, what is happening is Y has got off. Now, here the second car is climbing. X car has climbed. In scenario 1, this is where X climbs. Okay, so when Y climbs the bridge, time was 10 seconds. When X climbs the bridge, time was 80 seconds. So X took 70 seconds. Okay, X took 70 seconds to cover 500 meter. Okay, so in this case, 500 by 70 would be V1, which is what, like 7 point something. Okay, 7 point something meter per second. That would be the value of V1. But then if this is the case, okay, if this is the case, then this equation can possibly not be true. This cannot be true then. Okay, V1 minus V2, this cannot be true. Therefore, we completely rule out this option, and we now know that the situation, the scenario 2 that we considered was the actual applicable scenario. We have already got the value of 25. So from here we can get the value of V1 as 10 now. Okay, because 25 minus 10 will make 15. We have got both the speeds. I think we are done now. What is the speed V1 of the car on the road? That's 25 meter per second. What is the speed V2 of the car on the bridge? 10 meter per second. What is the length of the bridge? So in scenario 2, we have discovered that scenario 2 is applicable. In scenario 2, this is when the first car gets on the bridge, and this is when the second car gets, the first car gets off the bridge. So the first car stayed on the bridge in this duration. How much is that duration? That's 70 seconds. So the first car stays on the bridge for 70 seconds and it is traveling there with a speed of 10 meter per second. So the length of the bridge must be 10 into 70, that is 700 meter. So that would be the answers. All right, so the answers would be 25, 10 and 700. I hope you got the question, guys. I hope you understood everything. Okay, let's go to the next question now. Okay, all right, guys, good question again. So it says traffic signals are installed at every 1 kilometer on a long straight road. Okay, a signal remains red for tau seconds, which is 30 seconds, and green for the next tau seconds again. Okay, now the signals are synchronized in such a way that at a time the alternate signals remain red and the other remain, the scheme is shown. So guys, if at any point of time, if this is red, then this is green, then this is red, this is green, and after 30 seconds exactly opposite situation will be there. This red will turn into green, this green will turn. So at whatever time you have seen this situation, if you come back after 30 seconds and look at the signals again, this is what you're going to see. Understand this, guys. I'm not telling that the red has changed to green at the very moment when you are observing. I'm saying that you came, you took a picture of the signals. Okay, some was red, the alternate were green. You came exactly 30 seconds later and you took the picture again. You will just see the complement. You see the colors inverted, not literally inverted, like interchange. Like red will become green, green. And if you would have come and clicked the picture after 1 second, you would have found the same pattern. The ones which were red in your earlier diagram, in your earlier snapshot, they will again be red in your diagram. So can we say that if you come back after 60 seconds or multiples of 60 seconds, you are going to get the same snap again and again and again. And if you come back after 30 seconds or after 90 seconds or after 150 seconds, then you are going to get the alternate image. That means the signals which were red in your first image, they will appear green in your second image, and the ones which were green in your first image, they will appear as red in your second image. So we understand that if we come and see the signals in multiples, in odd multiples of 30 seconds, then we will find the situation to be interchanged. Okay, and that's the clue here. See, let's understand that this is the road, this is the road. Okay, and let's say these are the signals. So this is one signal, the other signal, the other signal, the other signal. They are all placed at same distance. Okay, at any point of time, if a car is crossing this signal, it must have been green at this very moment. I am not saying, guys, that it has just turned green or it is about to turn red. I am not saying that. I am saying at this moment, at some moment when it is crossing this place, the signal is green. It may have been green 5 seconds earlier, or 7 seconds earlier, or 10 seconds earlier, something like that. So it is green right now and the car is crossing. Now the car will reach the next signal in some time. Understand this, guys. If the car reaches here in exactly 30 seconds, okay, then this signal would also have turned from red to green. Not only that, the more important thing, let's say when the car was crossing this signal, it had been green for the last 7 seconds. This is important, therefore I'm going slow. When this car crossed this signal, it had been green for the past 7 seconds already. Now, if this car reaches this signal or crosses this 1 kilometer distance exactly in 30 seconds, then again this signal would have been green for the past 7 seconds only. Think about this. And again, when this car comes here, it would have turned green for the past 7 seconds. Understand this, like whatever time delta t, this signal stayed green, where delta t is less than tau. Okay, so this is the duration for which this signal had been green since last event of being red. Okay, if this car is crossing this much time, after this much time, and it takes 30 seconds to reach the other signal, every time it crosses a signal, this signal would have been green for delta t seconds. So it is bound to find all the signals as green. If it takes, let's say, 31 seconds or 32 seconds, then it may find this green, it may find this green, but eventually it will hit a red signal, because the gap is changing. This delta t, if it is taking 31 seconds, this will become 6 seconds. Let's say if we consider delta t as 7 as the example, if it takes 31 seconds to reach here, then this would have been green for past 6 seconds. Then 31 seconds again, it would have been green for the past 5 seconds, past 4 seconds, 3 seconds, 2 seconds, 1 second, 0 second, which means it has hit a red signal. So what we want to ensure is that when the car crosses a green signal, if it is taking exactly 30 seconds to reach the other signal, it is bound to find not only this one as green, but it will find all the other ones as green, which is the condition. Guys, what mistakes students commit in doing this question, they assume that they have to find out the time in which this car can reach here, and it may still find this as green. Now the condition is not to find this green, only to find this one as green. the situation demands that all the subsequent signals, which are infinite according to the information given in the question, they should all be found to be green, which means that this delta t should remain constant, and this delta t, okay, this is the time for which the signal turned green before this car crossed. Okay, this delta t will remain same only if this car is taking 30 seconds or odd multiples of 30 seconds to reach from one signal to other signal. So what I'm saying is that to cover 1 kilometer distance, the allowed values of time is 30 seconds or 90 seconds or 150 seconds or 210 seconds and so on. You can make this. So correspondingly, the allowed speeds are 1 kilometer by 30 seconds or 1 kilometer by 150 seconds or 1 kilometer by 150. Before 150 we'll have a 90 also. Okay, I'll write it here. So okay, so these are the trends. So if I find out this, if I convert seconds to hours, the allowed speeds are 1 kilometer by 30 into 60 into 60. The next allowed value would be 1 kilometer by 90 into 60 into 60. The next value would be 1 kilometer by 150 into 60 into, so do you see the trend, right? I hope you all see the trend. This is what, this 30 is 2, so this is 120 kilometer per hour, and then this value, whatever you have got here, this divided by 3 times, like this 30 has changed to 90, so that's there is a factor of 3 more in the denominator, like so this will become 40, then this has become 150, so 30 into 5, so there is a factor of 5 as compared to the first number, so that would be 24 kilometer per hour, and so on. You can continue this trend. So we can say that 120 divided by an odd number. Okay, so let's say 2n minus 1, where n belongs to integers. You can't put n as 0, so n starts from 1, 2, 3, 4, and these are the allowed values of speed. All right, students, so here we see these values. All right, and this s by tau is probably the 120 that we are getting. Okay, now coming to the 5th question. Okay, this question says an officer receives complaints of frequent traffic jam at traffic signal on main street of busy market. He studied the traffic pattern, and to simplify the calculations made a reasonable assumption that all the vehicles are identical in size and move with the identical speeds. At present, durations of red and green signals are equal, and average speed of traffic advancement is v1. For improvement in the situation, he orders to make duration of green signal 2 times and to leave that of red signals unchanged. What would be the average speed v2 of the traffic advancement? Okay guys, you can read the question. Okay, now let's understand first what is this means, average speed of traffic advancement. So where does the student commit mistake in understanding this question? They imagine a crossing, and they start thinking about how the cars are moving across this crossing, how much time they are taking to cross the signal, to cross this crossing, and something like that. They start thinking about that. Now guys, since I live in Bangalore, I am very used to traffic jams, and I totally understand when the question says what the rate of average speed of traffic advancement means. I totally understand this. To define this rate or to think about this rate, you don't think about the traffic signal or the crossing. You don't think about the crossing. You think about the queue. All right, that is there because of the situation at this traffic. Like the vehicles have piled up. Let's say this is the crossing. Okay, this is the crossing where the signal is present. Here is the signal. Okay, and you will notice that in cities, in most of the cities these days, but in wherever there is a traffic jam because of a signal, what happens is that there are cars here. Okay, if you have ever been stuck in a traffic jam, you will realize that your car moves very slowly here. Like when the signal turns green, your car moves at some pace, but then it keeps on standing at one place for some time. Then it again moves, and then it keeps on standing at there. Then it again moves, and then it keeps standing there. So let's say if we have watched a particular car for long enough period, we will say that this car was here, now it is here, and this much time has passed, so that's the average speed. Are you getting what I'm saying? That you don't focus on the signal, you focus on the cue. What happens is, every time the signal turns green, the car moves with a constant speed. That's the assumption. That speed is not given to us. Let that speed be v. So this v is the speed at which cars are driven. So the point is, whenever the car moves, it moves with a speed v, otherwise it is at rest. So when the signal turned green, the car would have moved some distance, then it stays there. Alright, then the signal again turns green, then the car again moves, and then stays there. So how do we calculate the average speed here? So the average speed would be, let's say, if tau red is the time, for which the signal remains red, and tau green is the time for which the signal remains green, which is initially given to be equal. Right now it's equal. Okay, then what we will say? We will say that car moves this much distance, tau green. Car moves this much distance in a total time of this much. Check this, guys. So whenever the signal turned green and it stays green, during that period the car moves with a speed v, so the distance covered would be v into tg, and then it stays at rest. Alright, and then the cycle repeats. So this distance was covered over a period of tg plus tr, because during tr the car was at rest, it did not cover any distance. Alright, so this will turn out to be the average speed v1, which right now is v1 into tau divided by 2 tau, because these taus are equal. Okay, so this is equation number 1. Now in the second case, what happens? The time for which green remains, the signal remains green, is made twice the initial value. So now the car moves for, let me use the symbol only, eta. It used eta. Eta was 2. Okay. So eta times tau into v. This is the distance cover in a period of this plus this. Check this. This is the time for which the signal remains red. This is the time for which the signal remains green. So this is eta v by eta plus 1. And how much was this? This was v by 2. So v1 was v by 2. So you replace v by 2v1. Okay. So eta into 2v1 by eta plus 1. That is your answer. Let's put the values. Eta was 2. v1 was how much? v1 was 1.5. Okay. 2 plus 1 is 3. So this becomes 4 into 3 by 2 by 3. So that's 2 meter per second. Bravo! The policeman, traffic officer, did a good job. He increased the average speed of 1.5 meter per second to 2 meter per second. That's almost 33% increase in the average speed. That's a good job. That's a good job actually. Alright students, I hope you understood the solution. I hope you specifically understood where does the, what is the catch in this question. Students, focus here. How the cars are crossing this, the width of the signal is not given, how long does it take. You don't have to focus there. Focus here. Focus on the cue. Okay. Alright students, I hope you understood this question. We haven't checked the answer, did we? We did not check the answer. Yes, the answer is 2 meter per second, which is the correct one. Alright.